Thanks. So I'm here to share TopNotch with you, a framework for systematically quality controlling big data that we at BlackRock have open sourced. I'm also here to ensure that we're all on time for lunch, so let's get started. Currently, building models in big data is a little bit like walking through a thunderstorm. You don't know when you're going to get shocked by data quality issues, but you do know that when it hits, it's going to hurt a lot. What we want to do is we want to make sure that we understand our data so that we can minimize the number of times that we get shocked and we decrease the pain that we feel when it happens. So, big picture, why do we at BlackRock care? So we at BlackRock care about making a better financial future for our clients, and we manage over $4.6 trillion in assets and we have employees around the world working in all different types of assets and all types of areas. I work in what is known as the financial modeling group. And within that, I work on building models to understand assets that are based on mortgages, credit card debt, and other types of debt. And following the 2008 financial crisis, you see a great increase in regulation leading to a lot more data disclosures. These disclosures greatly increase the size of the data sets that we need to model. Some of our data sets hitting 1 to 10 terabytes of size, meaning that our old modeling techniques no longer work. And we need to embrace new distributed techniques like Spark. So we want to have these 1 to 10 terabytes, but we can't trust their contents. They're often noisy, and this noise will destroy our models, because if we can't trust the input, we can't trust the output. So this is a big problem for us to handle, but we do have the vehicle to handle it, which is that internally, we have significant resources of 3,000 executors and 12 terabytes of RAM. So we have the tools we need. We just need a framework that will allow us to utilize them successfully. So we want to quality control big data, but that's a very nebulous topic. So we need to break that question down into 3 specific sub-questions that are actually solvable. The first is, what does it mean for data to be of high quality? How do you measure, how do you define this, and how do you have metrics of quality? Because you need to, in order to say that your data is high quality, you need to actually have reasons why. Second, it's going to take a long time to appropriately quality control any particular data set. But we have a lot of different data sets that are all big. So we need to make sure that once we quality control one, we can efficiently scale this up to many different data sets. Finally, we need to institutionalize the knowledge that we develop from quality controlling our data. Because we're going to have these market experts who are experts in the data set and spending a lot of time to make sure that they're right. We want to make sure that all of our employees, everyone working on the project, can learn from this expertise and know what's correct and what's incorrect without needing to waste the time of one person. So you might ask, hey, David, it seems like this is a well-solved problem because everyone has data quality issues. We're not the first company to see these issues. And that is true. There are a lot of great tools in the area, but they don't really fit our problem, usually because they either focus on cleaning data sets that fit into a single computer's memory, or because they focus on getting approximately correct queries. What we need to do is have rigorous knowledge on entire data sets, which is an unsolved problem, or at least there's significant space for improvement. So now let's make this problem concrete. Here's an example data set of a simplified version of something that we might see. It's going to be US mortgages, and you're going to have first your loan ID, so a balance on the mortgage, how much money is this mortgage, a FICO score, or a measure of credit, LTV, or a loan-to-value ratio, i.e. of the balance of the loan divided by the balance or the value of the house, the zip code that the house is in, and whether the owner lives in that house. So the first issue that we're going to see, as I've highlighted in blue, is that data could be missing or corrupt. And historically, the classic way to test this is to take some samples, look at it, do these rows look clean, off the cuff checking for things. And that's going to have 2 problems. A, that's not a metric. You don't actually know if that's right. And B, you're not checking for all possible failures, and you don't know what you're checking for. One person may check for missing values, another person may check for garbage values, like the meaningless signs, but you're not going to know exactly, these are the 7 conditions we checked for, and we know what we checked for. So we want to be able to rigorize that process and know exactly what we're checking and what we know. Second, there's going to be features that are going to be complicated to check for. We have a Canadian zip code here. It's going to be complicated to rigorously check that all zip codes are US and are valid US. Once we do this, we want to efficiently scale it up across all data sets. We know we'll spend a lot of time developing this check. We want to scale it up. And finally, we'll have issues that you'd only know if you're an expert in the data set. So here, you have that your balance on the loan is $1 million, but your the loan-to-value ratio is 400, meaning that the house is only worth 250,000. Now, an expert who looks at this says, oh, that's ridiculous. No banker is going to make $1 million loan for a $250,000 house. But you wouldn't know that unless you really knew and understood the data set. So once we control for this, we want to make sure that everyone else who looks for the data set understands this and learns from this knowledge. So we want to go from this really dangerous thunderstorm of a cloud to a much more tranquil environment where we know what we have and we trust our data. So the solution is TopNotch. And at its core, TopNotch is a unit testing framework for big data. The goal is to solve the most important problems and to rigorously solve those problems. The core part of TopNotch is the assertion. It verifies some fact about a data set. And it does this using a HiveQL where clause, essentially a derivation of SQL where clauses. And so what this does, it allows you to rigorously say, this is one small fact which defines a condition for validity. And then you can run that over your entire data set. And then you can combine these assertions to test for more complicated concepts. So these allow you to say, these are the facts I know. These are my conditions for validity. These are my valid data points, and these are my invalid ones. But we recognize that this is not going to solve all of your problems, because a lot of data isn't testable in this format. So that's why we've taken this command, if you can think of it like a shell command, and extended it with 2 other commands, 2 transformations, which enable you to manipulate your data to a point where you can run assertions on it and you can rigorously test it. The first is the diff, which will take 2 data sets of similar schema and do a comparison on them. Or, sorry, some subset of a similar schema and do a comparison on them. And then you're going to have your view, which will allow you to do arbitrary SQL joins to turn many data sets into one that can be asserted upon. And so what you do is you can take these different commands and put them into a plan, a shell script essentially, which is a series of commands which allow a diff to be the input to a view, the view to be the input to an assertion, and to combine all of these into an ordered series that tests for complicated concepts across a wide variety of input data sets. Also importantly, the plan handles all the file I/O. So your commands are independent of the data set that they operate on. All that they require is some contract of the existence of some columns, so that we can scale up what we do. Because you write a command once, and you reuse it across many data sets. So now let's examine, how do we solve those 3 problems I outlined earlier? 1, we want to measure and define data quality. Your assertions are your definitions and your metrics for data quality. You wrote those where clauses. You defined what it means for conditions for validity. And then we run those over, TopNotch will run those over your data sets and will produce reports, which are your metrics. So by defining your where clauses, you rigorously know what's valid, and you rigorously know how that applies to your data set. Next, we want to be able to scale this up. That's why we have the plan handle all the file I/O. You write the plan will handle the I/O as one JSON file. All your other commands are other JSON files that can be reused between plans for different data sets. And what that means is that you write the command once, you write an assertion to say, FICO's, the balance and the loan-to-value ratio have to be reusable. And you reuse it across data sets. And finally, we want to be able to ensure, again, that we institutionalize our knowledge. One data expert quality controls the data set, and everyone learns from that. And that's why your plan and your related JSON files are your summary. New user comes into a project. They look at a plan. They say, these are the 7 commands that are associated with it. They look at those 7 commands. Now they understand all the conditions for validity and all the manipulations associated with it. So we're documenting and scaling up that documentation for your data sets. So let's go through an example to see how TopNotch would actually work. So right now, we're going to have a monthly data process. Every month, we're getting in new data about loans. So in green, we have that new loan data set. And then we're going to have last month's data set as a point of comparison. But before we jump into that comparison, the first thing we need to do is verify that at the very basic, the new data set is internally consistent. So this is the type of report that you'd get when you run TopNotch. And so what you're going to see here is first, we have an English description of what an assertion is checking for. What we have here are 2 columns, CURBAL, or the current balance on the loan, and ORIGBAL, or what the balance was at the time the loan was made. So we're just doing a very basic check that over time, your loan balance is going down. This should make sense because usually people pay back their loan over time. So what we have is our query is the where clause, just a basic CURBAL is less than ORIGBAL. And then we have 2 columns that I want to pay attention to, fraction invalid and threshold. So in big data, we're not going to get everything perfect. You're always going to have that 1% problem, but this is big data, so I don't care. I want to make sure that we're right for the most important things on the vast majority of the data. You know, your 80-20 rule. So what we have is we have a threshold that says for if it's over 20% of the rows, then tell me. Then I'm concerned. Otherwise, don't bother me. And what we see here is that for our data set, roughly 40% are invalid. So this is a serious data quality issue that we would need to investigate. And TopNotch automatically pulls out with these reports samples of rows that were invalid with only the columns that you referenced. So you can immediately see in the report, hey, what's the issue? How do I diagnose it? And what are my immediate steps? We'll also generate data sets containing all the invalid rows with all their columns so that you can dive deeper if you need it. But this is your first quick look, quick glance. And note, this is not the final UI. This is just a way to show it in a clean way for the presentation. So now, let's say that we've gone back, we've talked to our data providers, we've fixed that issue, and we know that the data set's internally consistent. Now we want to compare it with last month's data set to know that what we're seeing makes sense in a historical context. So we're first going to run a diff command between this month's and last month's data set. And what you see is just merely we joined on the unique identifier, and we compared the columns. So we have the loan ID 31 and what the current balance is this month and last month. 280,000 versus 320,000. So it makes sense. Balance is going down over time. But what TopNotch also does is that first, if it detects it's a numeric column, we'll automatically do the diff for you. It won't do that if it's a data type for which minus is not defined. And we'll automatically say, are the types equal? Is there null issues here? And are they equal on an object equality level? So that you still get equality if it's a string or something else for which minus is not defined. So we see here how you rigorously get a diff that can be fed to other inputs, like an assertion, which can be rigorously tested upon and tested for validity for month-to-month transitions. So now we're going to run an assertion on that diff to see how things change through time. And since I've been talking for about 15 minutes, I'm sure you're all experts on this now. So would anyone from the audience like to come up and walk with me through an assertion? Anyone? Okay. Nope. Okay. So what we're going to do is we're going to have a report. Here's the report. And what we've done is all we're saying is we have our English description, which is that loan balances are decreasing from the previous month. So over time, are people paying their loans back, which is something we really would expect to see. And what we have is our where clause, which is just the query. And we're seeing that for 10% of the data, we're having issues. But our threshold is only 20%. So we don't really care. Because maybe there's some people that didn't pay back last month. Or there are just some minor data quality issues, but that's not really concerning us. We still get our samples, but we know that this is not a problem. So fine, we'll address this if we have time, but this is big data, so we probably need to move on. Oh, wait, no. Excuse me. So let's see how that was quality controlling one particular data set. But your ETL pipeline is going to be much more complicated than that. You're not going to be just having one data set. You're going to be getting raw data, and you're going to be doing transformations on it and manipulating it. So let's see how you would apply TopNotch to each stage of that process to verify all the different parts. First, you'd run TopNotch off your raw input, your CSVs, your tab delimited files, to verify that what you got in actually makes sense and is valid based on what you would expect. Next, you have your Parquet file. And so you do some type of transformation, maybe use the classic Databricks Spark CSV, or maybe you do something more complicated. Either way, you'd probably want to verify that that transformation is correct. So you'd have a different set of assertions and different set of commands to verify that, to know that transformation is correct. And finally, you're going to do some derived columns. You're going to have some advanced features that you're going to create pre-model creation. And you're going to run a quality control that to ensure that this stage of the process is also valid. So that if you get your analysis at the end and that there's a problem, it won't be, oh no, I have to go back and check the entire pipeline. It's not because without TopNotch, that's what you need to do. Your model is producing garbage output. You don't know where in the pipeline this is. And so you need to re-go through the entire pipeline to figure that out. With TopNotch, you would have asserted on every single step of this process. So you'd know where the breakage was as soon as it happened and went in and fixed it, which is going to really speed up your model process because you know if there's a failure, it's due to your actual model. So that's TopNotch for one model. But remember, one of our goals was to efficiently scale this up across all models. Right now, we have a lot of really great pieces, but they're just pieces, like screws on a bench. And what we want to get to is a much more organized system, where you know where your commands are organized, and they're just filed away. And so you need one, you just pick it out and put it into your plan, so that you can get started quality controlling your data much more quickly. So what we have not implemented yet, but as we go further through the open sourcing process, we propose is that you have your GitHub repos of commands. Commands are all JSON objects along with plans, so you would check them into Git repos with one centralized one. When you get a new data set or a new ETL format, what you would do is you would check out the relevant pieces. You say, oh, this is the command to check for LTV. This is the command to check for FICO score. And so you can do your data quality control trusting that experts have already verified parts of your data set for you. And then maybe you'd write some custom commands, and then you would put that back in the central repo. We're currently working on a front end to organize this and to make these commands better organized. And so that would mean that you could search for, hey, I want a command that checks for these 7 conditions, and not have to write it on your own. This enables learning of data quality control as a community. And this is enabled by the fact that everything's just a JSON file. So if you're as excited about TopNotch as I am, we're open source. You can take it, pull it, fork it, clone it. We're working on a front end as we speak, because right now everything is JSON in and Parquet and JSON out. And if you're interested, talk to me after the conference. I'll be at the BlackRock table, or email me. Thank you, and any questions?
You gave some examples of a problem like current balances and last month balances, but as you can imagine, you can have thousands of variables, and is there an automatic way of defining those assertions, or still you would have to have someone who understands the data and go through the 1,000 variables and the possible issues that might arise in order to define them? So I'm a little bit confused if you have a methodology that automatically will search for the issues, cover most of them, and some of them would still need to be defined, I guess, by the users. If you can address that. Thank you.
Yeah. So that is a concern that in very wide data, you are going to have a lot of different things to check for. Now, ideally, when you do your first data quality control checks, you're going to need an expert to look at that and make it valid. While you could do automated checks, and that's something that we're looking into, you want to make sure that when you're doing your quality controls, it's a human who actually knows what they're doing and actually analyzing it. You could expand your matching algorithms of your missing to say, if it's a column that looks like this, do it automatically. and that's an easy extension. But at this point, we do require that you match your columns.
Thank you.
Is TopNotch also corrective? So if you find a data quality escape, such as your Canadian zip code, can you look at the address and put the correct American zip code in or something like that?
So we considered that, but the issue with that is that you want all of your data modifications to exist in one particular place in the pipeline. And if TopNotch is going to do data modification for you, you're also going to have issue, and then you're modifying your data anywhere else in the pipeline. For controls, that will not be a centralized one document place for modifications. And so you might lose track of where your modifications may be. It is important, and it's an important feature, but as of this moment, we're focusing just on identifying the issues.
For these different rules, is it possible to use them with maybe another framework? Like, is it that we have to use all of it because some of this stuff sounds really useful, all the QC stuff, but we'd like to use maybe, your scripts that you use configured with JSON in our framework, and then kind of intermix the two? Is that really possible, or is it all kind of together?
So every step can output a Parquet file that you so the commands themselves have been designed to be inputs to TopNotch. The outputs are all Parquet files. Okay. So if your script can take a Parquet file, you can do whatever you want with it.
Hey, hi. Thanks for the presentation, but I have a question regarding how would you write an assertion based upon two dependent columns? For example, your example of loan and loan to value column. If you want to compare that value, like it's more than 400, which is not humanly possible. Yeah. So how is it working? How the assertion works? Can you just describe on that part?
Well, fortunately, I have a slide on this. Oh, okay. So this is the JSON file of what that assertion looks like. And so what you would just say is, I assume that there's a cur val. I assume that there's an orig val. I have some column. This is a valid where clause. And the parser will handle the evaluation for me. Does that answer your question? Is that?
Yeah. And internally, how it would work? How does it work?
So, yes. So we just put this into the SQL, into the excuse me. So with all data frames, you can run SQL queries on them. Because your inputs are some tab delimited file that we can convert to a data frame, or Parquet file, which you can convert to a data frame. We read it into a data frame, and we run it as a where clause in the data frame SQL query engine.
Do you have another question? Over here.
Hi, I have two questions. The first is, when you do validation in a pipeline of multiple steps, is the intent for the second step to wait for the validation to finish, or does it start and then if there's any issues found, it stops? And my second question is, do you have any support for streaming, or do you have any in the roadmap?
So the first question, is, forgive me. Wait, one more time. The first.
So if you have a multi-step pipeline.
Oh yeah. So if you have a multi-step pipeline, TopNotch won't actually be part of that pipeline. It's sort of a separate arbiter. So it's up to you whether you want to continue or wait. The recommended way would be run it in client mode, run yarn client, run a TopNotch script in yarn client. And so you can have it run as as a separate script, or have it run one process, run TopNotch, then run the next process. That's up to you. The report generation would be automatic, and you could say, we trust our process. Do it, and on the side, run TopNotch. And if there's a problem, I'll see the report, and I'll go back and fix it and rerun it. That'd be one way. That is up to you how to do that. And then with regard to Spark Streaming, at this moment, this is inspired by what we work on. And so at this moment, it solves our most important problems. It's something that could be addressed, but at this point, I'm not too familiar with the Spark Streaming API, so I can't comment.
Over here.
Hi. Great presentation. So the query there, could that also be a function? Or is it just kind of standard SQL semantics?
So it's HiveQL. And so HiveQL has an expanded syntax.
Yeah.
As well, HiveQL allows for adding in UDFs, or user-defined functions.
Okay.
So at this point, it would be it's not we have not looked into exactly how it's done. Theoretically, it's very easily possible. The actual implementation details of how you would add in UDFs are something that would still need to be worked out, but
Cool.
it's not a theoretically difficult problem.
Thanks.
Over here.
So I have a related pipeline question. Would it make sense to put TopNotch in your pipelines as you're going through, you're filtering out your bad results as opposed to just knowing that you had bad results? So in the case if you have 10% bad data, you're getting rid of it then, maybe you have 5% data later, and so you're eventually ending up with maybe 60% of your data, but it's good data. Is that a potential use case?
That is a potential use case. When we deal with data, if it's bad data, we can't just ignore it. From our perspective, it's something we need to. There are different ways to deal with data, obviously, and for some use cases, it might be useful to have that 60%. For ours, we try to address address the problem and then continue. But it would be very easy to extend it to say, give me the 60% and move on with my life.
All right, let's take one more question, and then other questions you can handle offline. Or if there are no more questions, let's give another round of applause to David.
Thank you.